Hi everyone. Today I'm talking about scientific notation, and so then if I get some time, I'll discuss about different units and all that sort of stuff. Okay, so scientific notation. If you ever wanna write some number, let's say a very, very small number, even like 345, in scientific notation format, what you need to do is to change this number to a number whose whole number is between 1 and 9. And depending on how many decimal places you went to the left or to the right in order to make the whole number between 1 and 9, you have to make that a power of that number. So say I go 2 decimal places to the left. Now the power of 10 would be 2. So always, this power depends on how many decimal places you went this way. Okay, so say another number, bigger number, and then 1, 2, 3, 4, 5, 6. 5 times 10 to the power of 6. So because this is an equal sign, if you punch this into your calculator, you will see you get 345 in the end. And then also, if you punch this into your calculator, you'll see you get this number. Now, this is for scientific notation for big numbers, but what about if your number is quite small? Let's say this number. So this is ridiculously small. Let's see what we get. 1, 2, 3, 4, 5. I have to go 5 decimal places in order to make this number a whole number between 1 and 9. So I go 348. See, this number is between 1 and 9. And then because it was 1, 2, 3, 4, 5 decimal places, this is to the power of -5. The negativity tells you your number is actually small. If your power is positive, you already know you're dealing with a huge number. If your power turns out to be negative, that means the number that you're writing the scientific notation for is actually a very small number. Okay, so that's about the scientific notation. It's really not more than that. So you just have to get your hands dirty on it and just make sure that you know what you're doing. So this is about scientific notation, but let's talk about some conversions and units and things like that. So in terms of conversions, say units for velocity or speed, both of them. The units for them is meters per second or kilometers per second or kilometers per hour or miles per hour or miles per second. You already know these things. Why? Because definition for velocity calls for it. Velocity or speed is basically distance or displacement over time. So if you don't like D for displacement, call it X. Anyhow, displacement over time. So now you can express displacement in miles, in kilometers, in feet, in inches, some length, or meters. Now for the time, you can express the time in terms of seconds, minutes, hours, right? So depending on what we have in the numerator as for our displacement and what we have in our denominator as for the time, then that determines the units for velocity. Okay? So that's pretty much all about, that's pretty much about velocity and, the units for it. But now let's move on to units for acceleration. So like I said, always see what your definition is for any quantity. So, for example, if you're dealing with velocity, because velocity is displacement over time, displacement is essentially some length, right? It's kilometers or miles or meters or inches or feet, whatever. Some length is displacement, right? Time is seconds, minutes, hours. And depending on what you have in the numerator and what you have in your denominator, then you decide about the units of velocity. Could be kilometers per second, kilometers per hour, miles per second, miles per minute, whatever. This over that. Now, in SI unit, velocity is meters per is expressed in meters per second. Why? Because in SI unit, length is in meters and time is in seconds. Therefore, meters over seconds gives you the velocity and the unit for velocity in SI system. Now, as for acceleration, and units for it, I already told you acceleration is change in velocity over change in time, over some duration of time, right? Okay, so, or, if I want to write it in terms of mathematical notations, I can just simply write A equals delta V over delta T. Now, depending on what velocity is expressed in terms of and what time is expressed in terms of, these two things decide what this is expressed in terms of, right? For example, if you have change in your velocity in meters per second, but your time is units for time is 1 minute, 1 minute, then acceleration would be meters per second per minute. Don't freak out. It's just, that's how things were expressed in terms of. It's definitely not an SI system unit. Nonetheless, it could be a unit for acceleration. So give this a factor of 1, meters times 1, then seconds times minutes, and that's totally okay. It could be the case where your acceleration, the units for your acceleration is miles per hour and your time is in seconds, let's say. Then the unit for acceleration, the unit for velocity was miles per hour and the units for time would be seconds. Now the units for acceleration would turn out to be miles per hour times seconds, and that's totally okay. Usually we don't have those crazy examples, but nonetheless, I'm just telling you that these exist, and just welcome it with open arms. Don't freak out if you see something that you haven't, it's just a little bit weird looking or anything like that. So always write what this is, and depending on how these are defined, then these two determine what this is defined, right? So in SI system, velocity, I already told you, it's meters per second. In SI system, time is also in second. So give this a denominator of 1. Then in SI system, acceleration, unit for acceleration is meters per second squared. So this is SI unit, but it doesn't mean that if acceleration is expressed in terms of, let's say, kilometers per hour per minute, is wrong or anything. This simply means that your delta V was kilometers per hour and your delta T was in minutes. So then, of course, then it turns out to be kilometers per hour times minute. Okay? I'll talk about different other things in the next video. Bye-bye.